So this is lesson 9.4 again, and we're just going to call it Completing the Square Part 2. Now we're using this strategy to solve quadratic equations. And again, in my mind, this is not the fastest strategy, okay? But this is an important strategy for what we need to talk about as our last strategy. So today's date is 5/9. So again, completing the square, here's what we have. First, we have only two terms, a quadratic and linear term. We need to complete that binomial and create a perfect square trinomial. So that's what that word completing the square means, okay? And the square means perfect square trinomial. So we need to come up with a number that's going to create a perfect square trinomial. So if I don't have a quadratic term and a linear term only, I got to get rid of whatever's bothering it. But what we didn't talk about on Friday is what does that quadratic term have to look like. So we're going to add a little component to it. The coefficient, what's the coefficient that goes with the quadratic term? What letter? What is it? X? No, that's the X, that's the variable. Coefficient is what's in front of it. So remember what standard form looks like. What's standard form look like? Okay, hold on, you went too fast. Standard form.
Sorry, I'm just erasing.
Okay, do it again.
Ax squared plus bx plus c
Okay, and you missed one thing.
equals
Thank you. Okay, so what's the coefficient of the squared term, the quadratic term? A. So the quadratic term, the coefficient A, and here comes the kicker, must equal 1. And the reason why we say this, it's really tricky to try to complete a square when there's a coefficient in front of your squared term. It's super big hassle. So that's something we didn't contend with on Friday because I specifically gave you just problems that it would work out neatly with, okay? So that's something that we're going to have to make sure that our quadratic term has only 1 as the coefficient. So if it doesn't have 1, let's say it has a 2 in front, what am I going to have to do to turn 2 into 1? Divide by 2, whatever that coefficient is. What do I divide by 2? Just the quadratic term? Everything. Okay, that concept, everything, did not show up on the test for every person. You do something on one side of an equation, you do it on all sides. You treat every term the same, okay? So that's kind of the new thing. So we have only the terms quadratic and linear. The coefficient A must equal 1. So the quadratic coefficient has to equal 1. So we'll write down step by step what we're going to do. Next, we're going to remember, because we're trying to create a trinomial square, so we want to remember what it looks like the other direction. So in chapter 8, the first half, we said, oh, if I have x plus 2 squared, and by the way, there is a question similar to this on the test, and what I saw over and over again, you squared the first term, you squared the last term, and you were done. When we square a binomial, we get a perfect square trinomial. Not a binomial, we get a trinomial. So we get x squared plus 4x plus 4. Okay? Notice, these two terms, if I multiply them together, equal 2x. To get to 4x, what do I need to do to that 2x? I need to double it. Why? Well, if I did this step by step, I would get 2x twice. That's the whole point behind squaring a binomial, is I get the same middle term twice, okay? I'm going to take that process that I just did, where I multiplied my two middle terms and multiplied by 2 to get to the middle term of the perfect square trinomial, and I'm going to do the opposite to that. So what we're going to do to figure out the constant that creates the perfect square trinomial, we're going to take our linear coefficient we're going to divide it by 2, that's the opposite of multiplying by 2, and we're going to square it in order to complete the square. Last term has to be a perfect square. So that constant that we're looking for, we're going to take the linear coefficient, we're going to take half of it, we're going to square it. Then what do I do with that term? What did I do with my equation now that has 2 terms on one side and a constant on the other? Morgan. It doesn't just become C, though. What are you going to do with this value? It doesn't go, it needs, remember, we got to treat both sides of an equation the same. So if I'm going to add this to the left side to complete the square, I got to add it to the right side to maintain the balance. Okay? So then we're going to add always. The squared value to both sides. So what I want to do is go through an example of this, maybe a couple, and then we're going to go and write down the steps in words, more with algebraic lettering, because that's going to come into play big time tomorrow, okay? All right, so this one, again, they're going to ask you to solve by completing the square. So we're going to have negative 2x squared plus 8x minus 18 equals 0. So job 1 that is new today that we didn't talk about before is my quadratic coefficient equal to 1? And the answer is no. So what do we need to do to get negative 2x squared to become x squared? We're going to divide every term, because we treat everything equally, by not 2, but that negative. That's the other thing, too, and we talked about this with factoring, is you really want that quadratic term to be positive. I saw in the test you guys left quadratic terms negative and got yourself messed up with signs. I saw a lot of people factor out a negative and not change any signs. So signs, you'll see I have written signs in big, bold letters several places on tests because that got overlooked. So this gives me a positive x squared, a negative 4x, a positive 9 equals 0. Okay, now what? Yeah, I definitely don't have a perfect square trinomial because, yes, 9 is a perfect square, x squared is a perfect square, but the square root of 9 is 3, and 3 twice is 6. We've got a 4, doesn't match. So we're going to get this constant to go to the other side. So now we have a binomial with the quadratic term and linear term, and that equals a negative number. So now we perform the magic act, right? Which is just a reverse of what we did when we were multiplying two binomials that were the same. If you feel more comfortable, I'll put the sign in. We take the linear coefficient. That's the b value. We divide it by 2 because we got the same middle term twice. We're going to take that answer and square it. So what's negative 4 divided by 2? Negative 2. What's negative 2 squared? 4. We haven't completed the square yet. We've got what we need to complete the square. Now we need to put it into place. So we get positive 4, adding 4, adding 4. Okay? So now I can factor this term. What's x squared minus 4x plus 4? What would I get if I factored it? Because I know I'm going to get the same binomial twice. So what's that binomial? X minus 2. Square root of x squared is x. Square root of the n4 is 2. The middle term was negative. And over here, negative 5 plus 4, or negative 9 plus 4 is negative 5. That's the pattern we came up with. You can always play the game if you don't understand. You can always play the game. If you've got a trinomial square, we have a pattern we can use to get to the factored version faster. If you don't understand that, just play the game. Okay? Okay. All right. So again, we're trying to solve. That means I want to know what x equals. So that's when I take the square root of both sides. And outside I have plus or minus. So here's what we're at. The quantity x minus 2 squared, the square root of that is x minus 2, equals plus or minus the square root of negative 5. And I'm going to tell you we have an issue. Anybody see the problem we have going on, Morgan? The issue is, what number times itself gives me a negative 5? It's impossible. Why is it impossible to come up with a number times itself that gives me negative 5? Pardon me? Okay, that's beside the point. I can get an answer by using a chart, and I can get a decimal answer, and I can round it. That's not my issue. What is it, the issue? Yeah. How do I get a negative product? Yeah, I would have to multiply a negative times a positive. If I have a negative number times a positive number, am I multiplying the same number by itself? No. If the signs aren't the same, they're not the same number. So this becomes an issue for you to have to watch out for. We actually cannot take the square root of a negative number in the real number system. Now, in Algebra 2, you're going to learn about the imaginary number system, and it'll give you a way to do this math. But we can't, with what we know, solve this problem. So how we respond to this is we say there are no real roots. And the reason why we throw in that word real is because there are imaginary roots. So when you get into Algebra 2, you start kind of talking about theoretical math. The what if math. The not what is math, the what if. Okay? So let's do one that actually works out. But I had to show that one to you. Let's do another one. And then we'll write down algebraically what are we doing. Okay? So we have 3x squared minus 9x minus 3 equals 21. Okay. Does my quadratic term have a coefficient of 1? No. So we can take care of that. Now, some people like to get the constant to the right side first and then get rid of the coefficient a. That's fine. I'm just going to get rid of the coefficient a. So divide everything by 3. Notice it's a positive 3, so I divide by the positive 3. So I get x squared minus 3x minus 1 equals 7. Oh, by the way, pull out those charts that I gave you guys, that table of square roots, squares and square roots, because we're going to use it in just a moment. And so that you can see how that table is going to come into play as you work on homework. So again, in order to play this game, I need to get the C term to the other side. So all I'm left with is a quadratic term and a linear term. So I get x squared minus 3x equals 8. Now I got to figure out what value would complete the square. So I take my number, and I can make it negative. I'm going to take half of it and I'm going to square it. And what do you notice is different this time than the ones we did Friday, the ones you had on homework, and the one we just did? Yeah. I cannot divide 3 or 2 into -3. So I leave it like that. And I square it. That means I square the -3, which gives me a +9, and I square the 2, which gives me a 4. That's the term that I now add to both sides, which creates a little bit of an issue over on the right side. I need to add that whole number with that improper fraction. So what I'm going to do is not change the 9/4 to a mixed number. I'm going to change the 8 to an improper fraction that matches so that I could add it to 9/4. So what are we going to change that 8 into? It's got to have a denominator of 4. So 8 times 4 is 32, and I put it over 4. Okay, now you're about ready to see a miracle. We know with the pattern, if I'm going to factor, I take the square root of the quadratic term. I take the sine of the middle term, and then I take the square root of the constant. What's the square root of 9/4? Have you seen that number someplace before? That is always the case. Always. Always. Look back here. -4 divided by 2 was -2. Squared is 4. Whoa! This guy is what I would get here. Okay? So we get all sorts of weird things happen when we start paying attention. Oops, that needs to change colors. Oops, sorry. Okay, so this is squared. Now, what do I have on the other side? What's 9/4 plus 32/4? Okay? So now I take the square root of both sides. I have a plus or minus over here. So I get the quantity x minus 3/2 squared. The square root of that is x minus 3/2. On the other side, I have a fraction. So what I'm going to do is try to take the square root of each of the parts. 41 is not a perfect square, so I leave it under the radical sign. What's the square root of 4, though? Yeah, so again, I'm looking at it as its parts. Okay, then we're going to keep going on. I want to figure out what x is, so I'm going to add 3/2 to both sides. And we get x equals. Now notice they both have a denominator of 2, right? The 3/2 has a denominator 2. The plus or minus square root of 41 has a denominator of 2. So what I'm going to do is write it as one big pretty fraction with 2 as my denominator. The numerator is 3 plus or minus the square root of 41. Now, in some worlds, that answer is sufficient. But in our world, it's going to have you round to the nearest tenth if necessary. Well, it's necessary. So here's what we do. Look at your chart. Find 41. Go over to the far right column for that number. And what is the square root of 41? Okay, tell me again. So it's 6.403. So that's what I replace square root of 41 with. And this is why I gave you guys that chart. And because the answers in reality, this, could you figure out where 4 plus square root of 3 plus square root of 41, boy, English, divided by 2 is on the x-axis? No. But we need, if we could get an approximation for the square root of 41, we would. So we're going to say that x is equal to 3 plus or minus 6.403 all over 2. So our two possibilities are x is equal to 3 plus 6.403 over 2, which gives me 9 plus 403 over 2, which when I do division, 2 goes into 9 4 times with 1 left over. 2 goes into 14 7 times evenly. It can't go into 0. And then I can stop. Why? Why can I stop? Because I'm running around to the nearest tenth. So I would say that x is approximately 4.7. The other one? X equals 3 minus 6.403 over 2, which gives me a negative 3.403 over 2. So I'm going to get a negative answer. So 2 goes into 3 once with 1 left over. 2 goes into 14 7 times. It can't go into 0, and then I stop. And I say that x is approximately negative 1.7. Do you see how many years of math show up in this one problem? There's adding and subtracting with integers. There's taking square roots of numbers. Normally you would be asked to estimate, but at this point we're going to use our chart. We're good with that. So you have to be able to read a chart. We're having fractions, right? And we have to understand that plus minus means 2 possible answers. So our solution set would be 4.7 and negative 1.7. That's where the parabola would approximately cross the x-axis. Okay? So, in all steps to complete the square. One, divide all terms by the a value. Two, subtract, the c value from both sides. Three, take the linear coefficient, which is b, cut it in half, opposite of multiplying by 2, then square it. So that would look like this, b over 2 squared. Okay. When I do that math, I get b squared over 4. Now, that's just, again, very generic what I'm doing. We're going to add this squared value to both sides of the equation. You're going to factor the left side, which remember is a perfect square trinomial, into a binomial that is squared. We're going to take the square root of both sides. Remember, plus or minus in front of the constant on right. I should say square root of the constant on right. And then solve for the values of the variable, which again are your roots where it crosses the x-axis. It's your x-intercepts. Now, we talked about there being a potential of 1, 2, or no x-intercepts. So it is potential that we get 1 answer, 2 answers, or no answers.